Quantum mechanics has revolutionized the world we live in, whether we've noticed it or not. You see, through quantum mechanics, we have things like our handphones, our laptops, even the GPS used to come here would not be possible if we didn't have quantum mechanics. But what is quantum mechanics? I mean, it's a strange word, right? Well, starting from the 1900s, many brilliant scientists were wondering, how does the world work on the atomic scale? Things like electrons, protons, neutrons. And what they found out was that the world of the very small behaves very differently from the world we see around us. You have very strange behavior occurring. Like, for example, you can have a particle being at two places at the same time. Or, like an electron, it has a particle behavior, but it also has a wave behavior. So all this peculiar behavior has been applied to technology, like semiconductors, MRI machines, and solar panels. There's so many things to number right now. And these are all from quantum mechanics. And now, is an especially exciting time for all of us, as we are part of this second quantum revolution. What's happening is quantum mechanics is coming back again and being applied to our technology. Soon you'll hear things about quantum computers, quantum algorithms, even quantum cryptography, where this peculiar behavior of quantum mechanics is applied to the world and technology we have right now. But let's look at search engines. If let's say you were to take out your phone right now and you Google something, maybe fake news, you will see millions of searches being done and being listed out and arranged from most important to least important in a matter of seconds, or at less than a second. And these are because of their search algorithms. And a lot of these search algorithms are built on something called the random walk. You can imagine the random walk as, okay, I'm a walker, and you flip a coin. If it's heads, I move right, if it's tails, I move left. Now imagine a whole network of these web pages, and you put walkers on all of them. And you let them move around randomly from web page to web page. You would see certain web pages having more walkers than others, and those are the ones that are ranked higher, more important web pages. But quantum mechanics comes and says, hey buddy, I can do this better than you. I can do it faster than you. But how? Let's look at peculiar behavior of being at two places at the same time. Now with quantum mechanics, you can have the walker actually spreading faster on this network and actually doing faster searches. But then you may ask, I only can search a few million web pages in less than a second. Why do I need quantum mechanics? Well, imagine you want to analyze your brain, a complex network of about 100 billion neurons. You need something fast, or maybe something more applicable. Let's say you want to design a drug. Right now, if you want to design a drug, it will take a lot of tests, clinical trials, keep trying and failing till you get statistically good results. Well, with the quantum walk, you can actually use it for pattern recognition to search for the right pattern of drug that you need to solve the problem. Therefore, we reduce the cost of drug production and we'll get more affordable and cheaper drugs for everyone. Thank you. Okay.
You had me at fake news. I've been having this debate with Facebook, and I might have to miss the final because they have invited me to go and debate more with them in Sydney. So my question to you is, I understand that the bots cannot crawl as fast as a tiny atom can really scroll around.
Yeah.
But the question is, the world of quantum mechanics itself is still a lot of mystery.
Yes.
So if we were to apply that to the most powerful social influencer right now, which is social media, look what happened when we just used normal crawling bots.
Yeah.
If we use what you're asking us to use,
Yes.
where do you think it will lead us to? Because this is what I want to put to task of all my scientist friends, including Abi. Sometimes we do our research without working backwards from where the outcome is going to be. So I'm going to put you to task here. What good do you think will bring as compared to the power that can go to bad, that could be unleashed by applying quantum physics to social media mechanics?
Sorry, let me rephrase the question. You're asking what would be the outcome of applying this quantum mechanics to?
Yeah, if we already have fake news because of these bots,
Yeah.
imagine if we use a more powerful tool like quantum mechanics.
Okay, well, I think the important thing here is that fake news has always been around. Just how fast can it spread? So if you have things like quantum mechanics being applied to search engines, of course, fake news can spread fast. But that would mean that it provides our government, it provides people in charge for a way to counter that by telling people, hey, this is not real. Hey, I've analyzed the network, I know where it's coming from, I know who's the source. And maybe that could even make people who are spreading fake news to be afraid. Because now we have even better tools to find out where is it coming from.
The impact might not be reversible. That's what I'm saying.
Okay.
You know, like nuclear bomb?
Yes.
Yes, we can control how many warheads,
Yeah.
but once it goes, isn't that the same for quantum mechanics if you apply that to the powerful super blue computer or whatever it is?
Well, that is humanity. Humanity has used science, the beauty of science, to do horrible things.
I need to be convinced.
Thank you. It's very good that he's trying to engage the fake news with quantum part. Now, since you are a physics student, I would like, which part of the quantum side are you using? Are you using quantum entanglement? Are you talking about photon spin? If you can narrow down, that'd be very lovely. Then you could basically look into the hacking side of such a system in the near future. Thank you.
Okay, for now, we can actually simulate this quantum effects, this quantum algorithms on classical computers. But what we want to do is that we want to have a fully quantum system. So there are a few systems. One is using ultra cold atoms. And the one I'm working with for my FYP is actually I'm simulating it using photonics, where we use a series of waveguides to actually be our quantum particle. So the effect we're using, since I'm working with a single photon system, I'm working with superposition and interference of their wave function. Whereas I could also work with entanglement and study their entanglement entropy. Thank you.
All right. Thank